Sathyabama Institute of Science and Technology.
Good morning. I'm Dr.R.Parameswari, Assistant Professor, Department of Mathematics, Sathyabama Institute of Science and Technology, deemed to be University, Chennai. Today we are going to see the topic, how we can solve the periodic function using Laplace transform. Laplace transform. First, I'll give you the introduction about Laplace. Simon Laplace is a French mathematician. He has done many application-oriented problems in mathematics, astronomy and physics, also in statistics. He began his work in calculus and which leads to Laplace transform. So, Laplace transform based on calculus, and he focused on celestial mechanics, and he is the first scientist who suggests the existence of black holes. Definition of Laplace transform. Laplace transform is an integral transformation of the function f of t, where t it is transforming one domain to the another domain. Okay, so that is what we are going to see as a definition. F of t from the time domain into the complex frequency domain, that gives you the answer as in terms of f of s. So how it is defined is L of f of t. Since it is Laplace transform, it is denoting as L f of t, and it is equal to integral 0 to infinity f of t e power minus st dt. And if we are integrating with respect to t and substituting the limit for t, we will arrive the result in terms of s. So, the resulting function will be in terms of s. So, that is what it is equal to f of s, and that s is real or complex. And this Laplace transform is called unilateral Laplace transform. Why it is unilateral Laplace transform? Because it is taking the limit from 0 to infinity. And in the two-sided or bilateral Laplace transform, the lower limit is minus infinity, and we don't use that. We will be using only the unilateral Laplace transform. Next, we are going to see the condition for existence of Laplace transform. So, there are two conditions. One is f of t must be single valued function, and it is single valued if it is divided into piecewise continuous, and in each continuous it is isolated. Okay, and the second one is f of t must be of exponential order. So, these two are the condition. F of t must be single valued and f of t must be of exponential order. If it's satisfying, if any function satisfying those two conditions, then we can use Laplace transform to find the solution. Now, we are going to see periodic function. Periodic function, it is if the function f of t is repeated in a particular interval, and it is denoted as f of t is equal to f of t plus t, where capital T is the period and it is satisfying for all t greater than 0, where t is a period of the function and that t must be taken as the smaller value which is not equal to 0. And for example, I have given this cos t, f of t is cos t, and if we are taking cos of t plus 2 pi, cos of t plus 4 pi, cos of t plus 6 pi, for all n values taking even integers, it will remain cos t itself. So, cos t is a periodic function with period 2 pi, and in the tan t is the periodic function with period pi. Sin t is also a periodic function with period pi. So, with that we can check. Now, we are going to find the Laplace transform of periodic function. So, it is a derivation actually. So, we are applying Laplace transform definition to that periodic function. So, the Laplace transform L of f of t is equal to 0 to t f of t e power minus st dt. T is divided into n. Okay, it is going on up to infinity. Laplace transform is defined as 0 to infinity. In that, I am splitting the integral limits as 0 to t, t to 2t and so on. And if we are integrating in this, every term we will be getting e power minus st, only the upper limits will be exist. Okay, because with this lower limit it will get cancelled. So, we can replace this by using t is equal to t plus 2t and substituting that as u, again you will be getting the limit is 0 to t. And combining all the terms together, here we are having one first term as it is, and e power minus st, e power minus 2st and so on. into integral 0 to t f of t e power minus st dt, and this can be written as 1 minus e power minus st the whole inverse using the binomial expansion. 1 plus 1 minus x the whole inverse is equal to 1 plus x squared plus and so on. So, using that we are getting this as 1 minus e power minus st the whole inverse. So, that is what we have written that in the denominator. So, Laplace transform of the periodic function is defined as 1 by 1 minus e power minus s into capital T, that is a period, and the limit is integral 0 to t f of t e power minus st dt. So, this is a derivation. So, Laplace transform of periodic function definition, you can remember this as the definition, the proof is given here. Now, we will proceed with the problem, and this problem is, it is defined as f of t is equal to t for the interval 0 less than or equal to t less than 1, and it is a periodic function with period 1. So, it is repeated again and again, and that curve is called sawtooth function. So, that is what it is given here as the diagram, and it is 0 to t. It is when I am substituting t value, it is 1. So, when I am substituting, it is repeated here. The period is t is equal to 1. So, we have L of f of t is equal to, what is the periodic function definition? 1 by 1 minus e power s t, capital T. What is t here? T is equal to 1. So, we have to substitute capital T value as 1, and integral 0 to t, t value is 1, and the function is t e power minus st dt. Now, we are going to integrate using integration by parts, because here we are having two functions t and e power minus st. So, we have to integrate using integration by parts. The extension of integration by parts is Bernoulli's formula. So, either you can use that Bernoulli's formula is the easiest one. What is Bernoulli's formula? Integral u dv is equal to uv minus u dash v1 plus u double dash v2 plus minus u triple dash v3 plus and so on. So, what we are going to do here? We are differentiating u and integrating v. And how we have to choose uv? We will be choosing using isolate. What is that isolate denotes? I represents inverse, L represents logarithmic, A represents algebraic, T is trigonometric, E is exponential. So, with that order only we have to choose whether which is u and which is dv. So, here u is t and dv is e power, exponential term is the last one. So, in isolate, so dv is e power minus st dt, and using that Bernoulli's integration by parts here we have used, since it is t power 1 only we are having. So, we can use by integration by parts. So, minus, actually t is u and dv is e power minus st dt. So, what is v? v is e power minus st by minus s. So, we have written here uv, u is t, v is e power minus st by minus s, that is between the limit 0 to 1, minus integral v du. V is having the negative sign. So, minus of minus becomes plus, and I took that 1 by s, the constant outside, and we are having e power minus st, differential of t is 1 with respect to t. So, e power minus st v du. So, that is dt we are having. Now, integrating this e power minus st, what we will get? We will be getting e power minus st by minus s again. Okay, that is between the limit 0 to 1. Now, substituting here the limit, we will be getting the first upper limit is 1 by s into e power minus s minus lower limit is 0. Here, of course, we should have the negative sign. We will check whether simplifying what happens. Okay, minus 1 by s squared into e power minus s minus of minus for the lower limit. So, that becomes 1 by s squared, and simplifying we are getting 1 minus e power minus s into e power minus s by s squared. So, L of f of t, that is for the periodic function f of t is equal to t, we are having this answer is 1 minus e power minus s into s plus 1 by s squared into 1 minus e power minus s. Okay, in the denominator we are having, that is we are having the denominator in the for the periodic function, the definition, right. So, at last writing that 1 minus e power minus s. So, this is a solution. We will see the next problem, and this is the square transform, and here the function is defined as minus a and plus a for the period t. So here the period is 2t. L of f of t is equal to 1 by 1 minus e power minus 2 st integral 0 to t f of t e power minus st dt. But the function is defined as between 0 to t and t to 2t. Okay. So in 0 to t it is a, and from t to 2t it is minus a. Okay. If you want to see the diagram again, I can go back to the slide. See, between 0 to t it is defined as a, and from t to 2t it is defined as minus a. So by the same way, for negative we are having minus a, for positive we are having plus a. Okay. So 1 by 1 minus e power minus 2 st integral 0 to t f of t e power minus st dt. And this integral 0 to 2t is divided into two subintervals. One is 0 to t, the other one is t to 2t. And for 0 to t it is defined as, the function is defined as a, and for t to 2t the function is defined as minus a. Both are constant. So only we are going to integrate that exponential term alone. Okay. So 1 by 1 minus e power minus 2 st, a is a constant, so we took a outside. Integral of e power minus st is e power minus st by minus, yes. So because of that we got the negative sign here, and it is between the limit 0 to a. And minus a is there already. Integral of e power minus st is e power minus st by minus, yes. So minus minus becomes plus, and it is between the limit t to 2t. Okay. Now we are going to substitute the limits. 1 by 1 minus e power minus 2 st minus a by s is a constant. So upper limit is capital T, lower limit is 0. Exponential e power 0 is 1. So e power minus s into capital T minus e power 0, so that is 1, plus this a by s is a constant, so we took outside, e power minus 2 st. Upper limit is 2t, so 2t we are substituting here, and lower limit is minus e power minus st. We can take a outside and s also outside. So a by s into 1 minus e power minus 2 st, and here e power minus 2 st, this is one negative, minus e power minus st, and this is one negative term, so minus e power minus st, plus 1, minus minus becomes plus, so plus 1. Okay. And here this 1 minus e power minus 2 st can be written as, it is of the form a squared minus b squared. So that can be written as a minus b, a plus b form. So we are writing 1 minus e power minus st into 1 plus e power minus st. And a by s is a constant outside, and this can be written as, it is 1 minus 2 e power minus st plus e power minus 2 st. It is 1 minus 2ab plus b squared, a minus a squared minus 2ab plus b squared form. So we are writing that as 1 minus e power minus st the whole squared. Okay. And here this whole square term gets cancelled with this linear term, and we left out with a by s into 1 minus e power minus st by 1 plus e power minus st. And if you want to simplify this more, you can simplify it. Next question. Find the Laplace transform of the function f of t is equal to. It is also divided into two subintervals, and here the function is defined as t in the interval 0 to b and 2b minus t in the interval b to 2b. So what is the period here? So here the period is 2b. Okay. Now we are going to start the solution. The given function is a periodic function with period 2b. So how will you write the Laplace transform? L of f of t is equal to 1 by 1 minus e power minus st, we have to write that t is 2b here. So e power minus 2b is integral 0 to t, so that is integral 0 to 2b e power minus st f of t dt. And this integral limit is now divided into two subintervals here also. One is 0 to b, the other one is b to 2b. So we have written that. And in that 0 to b, how the function defines? The function is defined as t. So here in the next step, we have written that. So 1 by 1 minus e power minus 2b is integral 0 to b e power minus st t dt plus b to 2b e power minus st 2b minus t, because in that limit it is defined as 2b minus t. So that is what we have written here. And now we are going to integrate. We are going to integrate and substituting the limits here. So 1 by 1 minus e power minus 2b is t into e power minus st by minus s. Here we have used, since it is two terms, we have used integration by parts by the Bernoulli formula. We have used Bernoulli's formula straight away. So, t is u, dv is e power minus st, uv minus u dash v1. Okay, that is what we have written here. So, it is t e power minus st by minus s minus 1 into differential of t is minus 1, and integral of this e power minus st by minus s is again e power minus st by s squared. Okay, so first term is over, and that is between the limit 0 to b. For the second term, u is 2b minus t and dv is e power minus st dt. So 2b minus t, here you should get t. 2b minus t e power minus st by minus s. Integral of e power minus st is e power minus st by minus s, minus differential of 2b minus t is minus 1. E power minus st by minus s integral value is e power minus st by s squared, and that is between the limit b to 2b. Now we are going to substitute the limits. So outside we are having this 1 by 1 minus e power minus 2bs as it is, substituting the limit for t. So it is minus b e power minus sb by s, and substituting the limit for the second term. So minus e power minus sp by s squared. Now we are going to substitute the lower limit. If you are substituting the lower limit, this term becomes 0 because t into we are having. And for this term alone we will get, that is equal to 1 by s squared we will get. Okay, 1 by s squared we will get. And for this, if I am substituting the upper limit term becomes 0. So only this lower limit, this term will exist, plus e power minus 2bs by s squared. Okay, and now substituting the lower limit, 2b minus b. So it is b by s into e power minus bs, and here minus e power minus bs by s squared. Okay, simplifying that, we will get 1 by 1 minus e power minus 2bs into 1 minus 2 times e power minus bs plus e power minus bs by 2bs by s squared. So again we can use that a squared, a minus b the whole squared formula. That is what we have used here, and here also we can use a squared minus b squared. A squared minus b squared is written as a plus b into a minus b, and this power 2 gets cancelled with this linear term. So now we are having 1 minus e power minus bs by s squared into 1 plus e power minus bs, and here we are taking e power minus bs by 2 common and writing that as 1 minus e power minus bs by 2 into e power minus bs by 2, and similarly here. So these two gets cancelled, and now we can simplify this and return this as 1 by s squared tan h of bs by 2. Okay, this is what we have discussed in this lecture. We'll see you in the next lecture. Thank you.